Hi, in this activity, I will be discussing three topics. Number one, basic transformations. Number two, transformations for complex movement. And lastly, advanced transformations. Transformations are operations that change the position, size, or orientation of a geometric shape or object. The first type of transformation is translation. A translation is a transformation that moves a shape or object a certain distance in a specific direction without changing its size or orientation. The second type of transformation is rotation. A rotation is a transformation that turns a shape or object around a fixed point, called the center of rotation. The rotation can be specified by the angle and direction of the turn. It could be clockwise or counterclockwise. And a third type of basic transformation is scaling. Scaling is a dilation or transformation that changes the size of a shape or object, either by enlarging or reducing it. In this section of my presentation, I will discuss the transformations for complex movement. In the context of complex movement, transformations refer to the mathematical operations used to describe and manipulate the position, orientation, and other properties of objects or entities as they move through space. Here are some key transformations used for complex movement. Number one, rigid body transformations. It is a combination of translation and rotation, representing the overall movement of an object in 3D space. Number two, affine transformations. It is the combination of translation, rotation, and scaling, providing a more general set of transformations for complex movement. Number three, coordinate systems transformations. Local to global. Mapping the position and orientation of an object from its local coordinate system to a global world-based coordinate system. Global to local. Mapping the position and orientation of an object from the global coordinate system to its local coordinate system. Number four, quaternions. Quaternions are mathematical representation of rotations in 3D space, offering advantages over traditional Euler angle representations, such as avoiding gimbal lock and providing more efficient computations. Number 5. Splines and interpolation. Splines are smooth, continuous curves that can be used to represent complex trajectories and paths for movement. And interpolation techniques such as Bezier curves and B-splines are used to generate smooth transitions between keyframes or control points. For the last part of this presentation, I will discuss the advanced transformations or the perspective. Perspective transformations are a set of mathematical operations used in computer graphics and image processing to change the viewpoint or orientation of an object or scene. These transformations are essential for creating realistic and visually compelling 3D graphics as they allow for the projection of a 3D scene onto a 2D display. There are several types of perspective transformation. Number 1, scaling. This transformation changes the size of an object, making it appear larger or smaller in the final image. Number 2, translation. This transformation moves an object along the X, Y, or Z axis, changing its position in the scene. Number 3, rotation. This transformation rotates an object around one or more of the coordinate axes, changing its orientation. And number 4, projection. This transformation maps the 3D coordinates of an object onto a 2D plane, creating the illusion of depth and perspective.